This is the last lesson on properties of logs, and this one might be a little bit longer because we're going to explore the flexibility of using the properties of logs and also try to put together the last 3 lessons so you can see how properties of logs are used to rewrite logarithmic expressions. So I want you to consider one of these problems, which is from the last practice set that you had. It was log base 2 of 25. And what I'm going to do is actually write that twice on here, log base 2 of 25, and show you 2 different ways that you could arrive at an expansion. So if the direction said to expand, there's 2 different ways you can do it. Now, the last lesson was using the exponent property where you take an exponent and you move it down front. And I had done a problem in the lesson that was similar to that. So probably the way that you did that problem was you wrote 25 as 5 squared and then took the 2 and moved it down front. And so you had 2 log base 2 of 5. Now, go back and check your work. So pause the video right now. Grab your sheet where you're doing your assignments for this and see if that's the answer that you have for that problem. If you don't have that answer, then correct it at this time. Now, there's another way you could do the same problem. Instead of taking the 25 and writing it as 5 squared, you might have written it as 5 times 5, which of course is the definition of 5 squared. And this would use the first property that we studied, which is when you have a product, you can write that as the sum of 2 logarithms. So you could have log base 2 of 5 plus, so you do the first factor, and then you'd have another log base 2 of 5 for the second factor. Now, if you have log base 2 of 5 plus log base 2 of 5, I could ask you the question, how many log base 2s of 5 do you have? And hopefully your answer there is 2. And so you have 2 log base 2 of 5. And what you should notice is that that is exactly the same answer. And it should be because you started with the same problem and got to the full expansion of it. And the point of this isn't to really prefer one method over the other. In this case, the method on the left is shorter than the method on the right, but mostly to illustrate that there's more than one way that you can do these problems. There's more than one way you can reason through them, and you can engage other things that you know specifically about exponents and order of operations to do these problems in totally different ways. So I really want to point that out, and as I'm going through some of the examples, I am going to pick a couple of examples and do them out more than one way so that you can see the different ways and maybe just kind of add to your own way of thinking of it, that there are some other ideas that you could try. And I've done this with my college algebra students, and they have come up with ways of doing the problems that I've never thought of. And it's just kind of cool and kind of fun. So there is, what we're going to do today in this lesson is go through combining all 3 properties. So in combining all 3 properties, in the previous 3 lessons, I have trouble writing and talking at the same time. In the previous 3 lessons, I gave you practice work that just focused exclusively on one of the properties. So now that you've had a chance to practice each of the properties independently, now we're going to put them together so that you're actually doing more than one property in a problem. And the trick there is learning which order. And sometimes there's some flexibility with that. So it's going to take some practice, and I am going to work 6 examples for you. And ultimately, most of the problems that we're going to look at in this class are doable in one step. Some of the really, really messy ones that we would see in college algebra would definitely take more than one step to do. But at this level, when we're first learning properties of logs, the problems that I'm giving you, I could do them all in one step. And I think a lot of you could do them all in one step. Maybe not at first, maybe not the first time you do them, but very quickly. So let's take a look at our expand examples. And this first one, I am going to do 2 different ways. I did mention I was going to do that. So this is log base 3 of 4n all squared. And the first way that I'm going to do this is I'm going to engage the power property, which is the one with the exponent. I'm going to take that 2 and I'm going to move it down in front. And now, when I look at it, I'll notice that I am taking the log of a product. And I know from one of my other properties that if I am doing the log of a product, I could write that as log base 3 of 4 plus log base 3 of n. Now, I did that in a different color because that is not something that I would expect you to write out. I don't expect you to write it out to the side. I'm only writing it out so that you have something to look at and you can kind of have something to visualize what it is that I'm saying. Now, here's the tricky part with this particular strategy. This 2 goes with the whole thing. It goes with the 4 and it goes with the n. And you can see that up here with the exponent. The exponent of 2 goes with the 4 and it goes with the n. So when you do that expansion, you actually need to put parentheses around it. So you need to retain that order. And then you can either leave it like that or you can distribute the 2 through the parentheses. So you'd have 2 log base 4, log base 3 of 4, and then 2 log base 3 of n, and you can write it like that. Okay, and now you've got it expanded all the way out. A different way to do that problem, same problem, so it's log base 3 of 4n all squared, is you'll remember that just a moment ago I said this 2 goes with both the 4 and the n. That is using your properties of exponents. So again, I'm writing this out to the side as a part of explaining it. I don't expect you to write this out. And I don't know why I put a 3 there instead of a 2. Try again. That means 4n times 4n, which of course would be 4 squared and n squared. So 4 times 4 and n times n. And that's one of those properties of exponents. So you could do, as your first step, you could use a property of exponents. Now we'll use the product property there, where we're going to take the logarithm of the first factor, which is 4 squared, times the logarithm of the second factor, which is n squared. So this would be log base 3 of 4 squared plus log base 3 of n squared. And now I'm second guessing what I said again. That's like a theme with these videos, is I'm saying something and then after I say it, I'm like, did I say what I had in my head that I was supposed to say? Now, you can expand it further by taking the exponent and moving it down front. And so this logarithm here has an exponent of 2. That's going to come down front. And then this logarithm over here also has an exponent of 2, and this is going to come down in front of that logarithm, so it doesn't kick all the way back to the beginning. It comes down right in front of that logarithm. And what you should notice is that this answer right here is the same as this answer here. So 2 different ways of going about it, but you land in the same place. So what you might want to do right now is just pause the video and kind of click back and forth between the 2 examples and just see which one suits your personal style better. Which one do you like, or do you not have a preference? I don't really have a preference, but some of you might. You might have like, oh, that way made more sense to me, or like this way I would have made a mistake. Okay, let's take a look at a couple more examples. We have the natural log of x, y all over z. So here, right there, in between the x and the y, we have multiplication. And then here we have the division. And if you were doing this out, you would look at this and you would say, okay, I'm going to do x times y and get a product. And then take that product and divide it by z, probably. When you're going to do the expansion, you're going to reverse that. So if you would have started with the multiplication and then done the division, if we're going to undo it and kind of deconstruct and expand this logarithm, we're going to start by undoing that division. And so we're going to start with natural log of xy minus, because xy is the numerator, minus the natural log of z. And I don't know why I changed it my l's. Those are both l's. And now I will expand my numerator. So the natural log of x times y is the natural log of x plus the natural log of y. And then, of course, we have the natural log of z. And there you go. There's the full expansion of it. Any of these problems that you feel like you're not totally following what I'm doing, pause the video, rewind it, and just hear the explanation again. Give yourself a chance to hear it and see it, maybe even write it down more than once to let the information soak in. So sometimes the first time through is just not enough. And I am talking kind of fast. Last one here is the log of x squared over y. And so here are the two properties. You've got the exponent of 2, but the exponent of 2 is only on the x. It's not on the y. So you don't want to move the 2 down front because then it would be going with both the x and the y, and that's not the way that it's written. So those of you that have kind of played fast and loose with where you're writing things or whether there's parentheses and paying attention to what goes with what, it really will mess this up if you're not paying attention. So we'll start this one by undoing the division. So we'll have the log of the numerator minus the log of the denominator. And then after we get it like that, now I can move the 2 down in front. And now it's only going with the x, not with the log of the y. And that's what it looks like to expand them. And really, there is a pattern to the order that you do things. And I can do that in one step, and it's not an issue. Let's take a look at some collapsing problems. So collapse examples. And again, with this first one, I'm going to do it 2 different ways so that you can just see that there are different ways of working these problems. So we have 3 times log base 2 of x minus 4 log base 2 of y. So here's what I got going on. I've got some coefficients, and I know coefficients can move into the position of exponents, and I also have a subtraction right there. And subtraction, I know, will collapse into a quotient. But if I don't really want to collapse it first because I have that 3 and that 4. So the first thing I'm going to do is take this 3 and move it into the exponent of the x, and I'm going to take that 4 and move it into the exponent of the y. So we have log base 2 of x to the 3rd minus log base 2 of y to the 4th. Now I've got it cleaned up, so now I can take that subtraction out by writing the log of the first argument divided by the second argument. So this would be log base 2 of x to the 3rd over y to the 4th. And again, without a whole lot of practice, you will be able to go from here to here. Now, for fun, because why would we not want to have fun? I'm going to do this problem a different way, just to explore some things like, what if I did this? Would it still work? So with this one, I'm going to start essentially the same way. I'm going to move the 3 and the 4 into the exponent. But this time, instead of moving the 4, I'm going to move the negative 4. Because if you think back to the very first day of school, and I know we're kind of inching closer to the last day of school, so you probably don't want to think back to the first day of school, but I said there's no such thing as subtraction. Subtraction just means adding a negative. So could we put a negative 4 into the exponent, and then this would become addition, because the negative got moved into the exponent. All right, now I have addition, which means that when I combine these two, I will multiply them. So we'll have log base 2 of x to the 3rd, y to the negative 4th. And here's the little piece of information that you want to remember. Something to a negative exponent means that you change its position. So a negative exponent in the numerator would become a positive exponent when you move it to the denominator. You're not going to move the x to the 3rd because that's got a positive exponent, but you will move the y, and then when you move it to the denominator, the exponent would become positive, and it's the same answer. Shocking. Not shocking at all. Now, I don't think I would recommend this way of doing it because it introduces a negative exponent in a place where you don't need a negative exponent, but I think it's interesting to note that it can work that way, that is a way of doing the problem, and that with the laws of exponents kind of kicking in, it works just as well and should arrive at the right spot. All right, a couple more examples of the collapsing. We have natural log of x plus the natural log of y minus 3 natural log of z. So I've got a bunch of stuff going on here. I have adding, I have subtracting, and I have a coefficient, but it's okay because we know what to do with all of these. So first thing I need to do, because I can't do anything as long as I have that coefficient, that 3 has to kick over into the exponent. So we'll have natural log of x plus the natural log of y minus the natural log of z to the third. Now I'm going to work from left to right. So if I have two logarithms that are added together, I can write those as a single logarithm and multiply the argument. So we'll just do x times y, and then I haven't touched this log, so that's still there. And now I know if I subtract two logarithms, I can write that as a single logarithm, and then take the first argument, and that'll become the numerator, and the second argument would become the denominator. And now you've collapsed it all the way. Easy peasy. And for whatever reason, I don't have a third example of collapsing. I can make one up. I don't know, what could go wrong? Let's do log of x plus 4 log y minus 2 log z. Okay, now for this one, I'm going to demonstrate how I can do this in my head. Okay, it's one step problem. So I know that adding means I'm going to be multiplying the x and the y, and the 4 here I know is going to become the exponent. So I'm going to have log, and then that I'm going to have x y to the 4th. Then this minus sign means that I'm going to have division, and this 2 is going to move to make that z squared, and so the denominator is going to be z squared. And there's literally no work to show for it. And I am 100% okay with you guys doing that. 100% okay. Now, here's what the steps would look like if you were going to do out all the steps. So you'd start by moving the coefficients into the exponents, and then you'd work from left to right. So you would combine these two over here. Whoops. There we go. These two over here, x, y to the 4th, would combine together. And then your numerator would be the x, y to the 4th divided by the z squared. And so there'd be two intermediary steps there, and you're totally okay to skip that. Now, just for a point of reference, I would consider these problems a moderate level of difficulty. They do get like much messier, so you can like throw a lot of like square roots in there and try to deal with like exponents of 1/2, and certainly put like a lot more variables in there and throws, yeah. And they do get quite challenging. This is about moderate, so the first problems that we were doing would be classified as easy, and then when you start combining them together, you kind of move up to the moderate level. We're not going to touch like the really hard level, and for those of you that go on to pre-calculus or go on to college algebra, like you will see more challenging ones then, but you will have seen the properties before, so it's not like you're going to be trying to learn the properties and apply them in a really hard setting at once. You're getting this chance through it to kind of learn the properties. So on your piece of paper, you have up through however many we've done. We've done 24, and so you've got your previous assignment. And as with all of the assignments, I am going to do the expand problems on the left and the collapse problems on the right. And here they are. As before, I will read them out loud so that if there's something that's not written clearly, you can hear me say it. Number 25 is log base 4 of x squared over y to the 4th. 26 is the natural log of x to the 3rd. That 3 is a little messed up. So x to the 3rd, y to the 4th, z squared. 27 is the log of x, y squared all over z. 28 is 3 log base 4 of 5 minus log base 4 of 2. 29 is 2 log x plus 3 log y minus 4 log z. And 30 is log x minus log y minus log z. I'm going to put a little asterisk next to this one because you have two subtractions happening there. So obviously I want you to try it, but it's not one that's been modeled for you. And it's going to look a little yucky at first, but see what you can do with it. And that completes our lessons, our series of lessons on properties of logs.